Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now what is the major product of these reactions? It's the meta-substituted this ether. Now what reagent I have provided? Sodamide in liquid ammonia. See, this is actually, you may consider the proton, if you remove one proton from ammonia molecule, this is produced. So it is NH2 minus, amide anion. I mean two lone pairs are there, and it's a sodium salt. Remember, this is actually, student, this sodamide is a very strong base. Why? Because if you look at the electronegativity value of nitrogen, it is not that much higher like oxygen, that is 3 nearly 3.5, nitrogen nearly 3. So it is not that much strong electronegative. Second thing, electron density on this nitrogen atom, it's a 2 electrons are there, high electron density. It is not that much stable, and alkali metals are stable, so it also allows this electron density. It doesn't help to stabilize. So this is a very strong base. Now it's a base. Second thing, you can say, sir, can't this NH2 act as nucleophile? Maybe it can, but if you say consider this is a nucleophile, what is the electrophile? You can say, sir, CBr bond here, this carbon is delta positive, bromine delta negative. So remember, aromatic halide, when you have a aromatic carbon halogen bond here, bromine, these SN1 not possible, because then carbocation need to be generated here, which is on sp2 hybridized carbon, and that is not in conjugation with benzene, and SN2 not possible because backside attack not allowed, benzene ring electron cloud there. By the way, I have already discussed a dedicated lecture on this topic. You may visit for further learning. Now, this much we understand that nucleophilic substitution directly not possible, SN1 SN2. So acid base reaction will happen. The question is, if you look at this molecule here, sp3 hydrogen, and there are sp2 hydrogens, 4 sp2 hydrogens. So we know the sp2 hydrogens are more acidic compared to sp3 hydrogen. So one of the sp2 hydrogen will be abstracted. Question, who will be abstracted? That is actually determined by the stability of the conjugate base. Means if you remove the proton, whatever remaining, that is called conjugate base. So let's look at the conjugate base. So if you remove this H1, carbon ion will be generated. So this is actually the C. Now if you look at this conjugate base, it is in between the two electronegative atom, oxygen and bromine. Remember, halogens are overall deactivating, means their minus I is stronger over their plus R or donating, and oxygen is obviously donating, I agree, but still it has some sigma withdrawing or minus I effect. So it is true that this carbon ion is very reactive, but from nitrogen minus to carbon minus is generated, and it is very reactive. It is actually somehow little bit stability because of this withdrawing effects. Point number one. Now if you look at H2, this hydrogen removal, negative charge is here, which is only stabilized by Br, because minus I doesn't operate from this long distance. So it is 1 2 3 4 5, no, not possible. So it has very less stability. That's why this proton is actually, student, less acidic. So compared to this, H3 is far less acidic because it is equally long distance compared to this Br as well as this OCH3. So it is far less stable. So it is not possible. If you look at here, you can only these minus I of these oxygen operating with respect para with respect to these bromine, so it will not help to stabilize. So one thing is clear, that this not possible, this not possible, this is also not possible. So only H1 could be abstracted, these NaNH2, I mean this NH2 anion. Okay, so if it abstract this proton, what it will produce? It will produce a carbon ion. Student, let me draw the first here negative charge, and here OMe, and this is Br. Now what can happen? By the way, remember one thing, this negative charge is actually in the sp2 hybridized orbital, and by the way, it is not in conjugation with this benzene ring. Now what will happen? So these will make a overlap with this carbon bromine bond, and based on this overlap will happen, which will make this bond unstable. So very easily, if I say, you can expect that, sir, OMe this is Br, so this negative charge will push and it will come out. And what will result? It result in another bond. By the way, the inside part is actually aromatic. 6 pi electron are in conjugation, but if you look at this is not in conjugation. Remember, it is not in conjugation. Why? Because look at the parent carbon ion. This charge was in sp2 hybridized orbital. This sp2 hybridized orbital was perpendicular compared to the p orbital on this carbon, which was responsible for aromaticity. So they cannot come in conjugation because they are not in same plane. Second thing, if you look at these pi bond, look at very carefully. So here in this way, this sp2 hybridized orbital, this is in this way. So it is not a proper overlap. So this improper overlap of these two sp2 orbital results an unstable bond. So this bond is actually unstable too. If I say unstable, you can say, sir, it's more reactive. Yes, student. And this, because of this more reactivity, a nucleophile can attack on this carbon-carbon multiple bond. Do not get confused this with a simple carbon-carbon double bond or carbon-carbon triple bond, because simple normal carbon-carbon triple bond nucleophilic attack is not favored. Why? Because these pi bonds are electron rich, nucleophile is also electron rich, so that will repel each other. But since this molecule is not at all that much stable, so nucleophile can attack. What is nucleophile here? Obviously this NH2. So first case, this NH2 act as base, and second case, this NH2 act as the nucleophile. Now your condition, that said, two option possible, either here or C2 or here C3, where the nucleophilic attack will happen. Student, that will be decided by the stability of the product. So if nucleophilic attack happens on C2, then here NH2, this is OMe and negative charge is here. Because nucleophile will attack, it will be opened up. One option. Now second, there could be another option. Means this NH2 can attack here and it can open up. I mean attack on C3. So it will produce negative charge in between here. And obviously OMe and here NH2. By the way, if you look at previously, this negative charge was stabilized little bit about the minus I effect of this carbon nitrogen bond. But here at this position it is relatively more stabilized, because both the minus I of this nitrogen as well as this oxygen both are working to stabilize this negative charge. Consequently, this is relatively more stable. So it will be produced. And by the way, I should have been mentioned one thing, that the second step is, student, actually workup, because if you do such kind of strong base mediated reaction, workup is essential. And after workup, what will be done? So these negative charge will be quenched to finally produce this thing. So here 1,3 substituted or meta substituted, this derivative will be produced. So what is the answer? Obviously option D is the right answer. Now I guess you have understand from this. Now you may think that, sir, why not this substitution? This is not the product. For that you need to understand again that these carbon ion may result that product, but this carbon ion is not that much stable, so it will not be produced. So if it doesn't produce, then the benzyne from this, I mean this benzyne needed to prepare that product, so these benzyne will not be produced, so that product formation is not possible. So I guess you understand. Ortho I have explained, not possible. And why not this Br leave? By the way, then these NH2 need to attack on this bromine, which is not that much stable, student, compared to this. And by the way, if you look at NH2Br, this product is also not stable, because this both electronegative atom lone pair, there is lone pair, so repulsion will be there, not a stable option. So this is also not possible. So option D is the right answer. This is a very interesting problem where, remember, the benzyne is produced as the intermediate, and through more stable pathway or less energy associated pathway, this is produced. By the way, benzynes are very reactive reaction intermediate, but I have discussed about the relatively stable pathway. So that is the reason for the selectivity of the product. By the way, I've already discussed few lectures related to this. I request you please check the I button as well as description box where you get some related lecture. So this is the end of discussion. I thanks everyone for watching. See you in my next video. Bye bye.